there are two types of resistors which are widely used in electronics. One is coiled resistor and the other one is my carbon resistors. Before going to the carbon resistors, let us go to the coiled resistors. These coiled resistors are also called the wind or wind resistors. So here what happen is we take a non-conducting core, okay, and on this we make a coil of that wire, and that wire is not the ordinary wires, these are alloys, okay, these wires are my alloys, okay, ALLOYs, these are alloys. Example, say nichrome and Constantan, Constantan, etc. So these are widely used. Constantan are widely used in the laboratory resistors. Okay, so this is a mixture of say copper and nickel. Okay, and copper has got 55% and nickel is 45%. Similarly, this nichrome wire is a mixture of nickel and chromium. This is 80% nickel, and chromium is 20%. So these are alloys. So there are so many types of alloys. Okay, so this Constantan is widely used like this. Okay, this is a Constantan resistance box. Inside every box there is so many coil of Constantan wire, so that this Constantan will be used as coil resistors, because these are alloys who have got high resistivity and high resistance. Because of the high resistance, these can be used as the coiled resistor like this. Okay, so this is my Constantan wire, and which is winded all around. If you see it, all around this core. This core is non-conductor, and the non-conductor may be ceramic. So this core is non-conductor, maybe a ceramic or any plastic substance. Okay, so this is how it is winded. Another thing, why do we use an alloys for making a wind coil resistor? Because we saw that in the last lecture in the graph, that for alloys this was resistivity or resistance and this was temperature. We got this kind of graph for alloy. Remember, very important for examination, any examination, very important. If you see, whenever you increase the temperature from this, the resistivity is not changing widely, the resistivity is very slowly changing. It means that the resistivity is very high. Alloys have got high resistivity. Number one, why? High resistivity. Number two, do not react very fast with temperature. Okay, if you even increase the temperature, it will not react very fast like a metal. Okay, like a metal like this. Metal was responding like this, which is abnormal increase in the resistivity or the resistance with increase in the temperature. But the alloys do not. That is why we use nichrome and Constantan as a coiled resistor. Number third is from the chemistry, that alloys do not form oxides easily. Okay, these are the very three basic points, that it do not form alloys. It do not react with what? It do not react with the oxygen to give rust. Okay, so if you keep for so many long time, it will not give you rust. So it has got a very long life. Now what is the disadvantage? Why do we do not use resistors in all the devices. Why do we use carbon resistors? Is that the alloys resistors or resistors, coiled resistors, okay, give up to few, very remember, few ohm resistance, okay, so few kilo ohm, maybe it may give 1 kilo ohm resistance, may give 3.1 kilo ohm resistance, it may give 2.8 kilo ohm resistance, it may give 5.0 kilo ohm resistance. But if we want to have 100 kilo ohm, if you want to have 500 kilo ohm resistance, then we cannot use a nichrome wire, we cannot use a tungsten wire. That time we have to use another kind of resistors, which is called carbon resistors. Okay, I will show you how it look like. I have got so many, I have kept here. So carbon resistors is my next topic. Okay, why it cannot be used? Because it will only give to the few kilo ohm, 1 kilo ohm, 3 kilo ohm, like this. By the way, what is kilo? Kilo means 1000, okay? Kilo means 1000. 1 kilo means 1000. 2 kilo means 2000, okay? Like that. So next topic is my carbon resistors and its color coding. Thank you.